How did the universe go from 0 to billions in an instant? Today we are going to talk about cosmic inflation. This is one of the most mind-blowing theories in all of science. In just one instant, our universe went from being smaller than an atom to being billions of light years across. And that's the topic for today. So let's take a look at what happened before the Big Bang. Most people think of time beginning with the Big Bang. But according to the latest research by NASA and other space agencies, this could not have been the case because time needed to be created first. According to scientists at the University of Göttingen, our universe was so small it was literally zero. It had no size. And then something crazy happened. The universe expanded faster than the speed of light, which is the fastest anything can move in space, in less time than it takes for light to move 1 nanometer, which is 1/1 billionth of a second. Our universe expanded by a factor of 1 followed by 26 zeros. Yes, that many zeros. Our universe went from 0 to billions in a flash, and that flash was the Big Bang. So how does this happen? Well, it's due to quantum fluctuations in a field called the inflaton field. Quantum physics says that even in a vacuum, there are fluctuations or jitters that happen constantly. You might remember those old school cartoons where they show an empty space like a vacuum, and then suddenly, there's a little rabbit that pops out of nowhere. That's kind of like what happens in a vacuum according to quantum physics. Now imagine that this jitter in the vacuum causes the entire universe to expand rapidly. That's exactly what happened. Those tiny quantum jitters cause the rapid expansion of the universe, and we call that cosmic inflation. Think of it like you re-standing in an empty room, and then suddenly the walls start moving away from you faster than the speed of light. That's what would happen if the inflaton field started to fluctuate rapidly. Or imagine you're standing on a beach watching the waves crash onto the shore. As the wave approaches you, it seems to be coming towards you at a constant rate. However, once it hits you, you realize that it was actually moving faster than the speed of light. That's because the wave crest has already passed you, but the trough of the wave is still moving towards you. Similarly, the expansion of the universe during inflation may have appeared to be slower than the speed of light from our perspective. But in reality, it was happening much faster. You might be wondering why this happened. Why did the inflaton field start to fluctuate in the first place? Nobody knows for sure, but scientists believe it may have something to do with dark energy, which is a mysterious force that makes up around 80% of the energy in the universe. Dark energy is thought to be the driving force behind the accelerated expansion of the universe, but we still don't know much about it. It could be that the inflaton field is related to dark energy, or that they both related to something else entirely. But for now, the jury is still out. What we do know is that this rapid expansion didn't last forever. Eventually, the fluctuations in the inflaton field calmed down, and the rate of expansion slowed to what we see today. This period of rapid expansion is known as inflation, and it's thought to have occurred within the first fraction of a second after the Big Bang. Now you might be wondering, why do we even need this theory? What problem does it solve? Well, there are a few issues with the standard model of cosmology that inflation helps to address. For example, one of the biggest problems is the horizon issue. This is the fact that the universe appears to be the same in all directions. But if that's true, why can't we see what's beyond the horizon? If you've ever driven on a highway and seen the road stretching out in front of you until it disappears into the distance, you'll know what I mean. The universe is much the same. We can only see so far because light has. It's only had a finite amount of time to travel to us since the Big Bang. But if we could see beyond the horizon, we would see things that are much older than the universe itself. And that doesn't make any sense. But inflation solves this problem neatly. If the universe expanded rapidly during inflation, then everything would have been much closer together, and light would have had enough time to reach us from all parts of the universe. Another problem that inflation solves is the flatness problem. This is the fact that the universe appears to be flat on large scales. But if that's true, why isn't gravity pulling everything together? According to Einstein's general theory of relativity, gravity should cause the universe to collapse in on itself. But we know that's not what's happening. Inflation gets around this problem by providing a mechanism for the universe to have been created in a state of near-perfect flatness. Finally, inflation also helps to explain the existence of large-scale structures in the universe. The galaxies and galaxy clusters that we see today are all grouped together in these massive structures. But if they were all close together during inflation, then they should have stayed that way. Inflation stretches the universe so much that it would have smoothed out any initial variations in density. But we know that didn't happen because we see these large-scale structures today. Inflation solves this problem by introducing a small amount of curvature into the universe. This means that gravity would cause matter to clump together over time. There's still a lot that we don't know about inflation. For example, we don't know exactly how long it lasted, or what caused the fluctuations in the inflated field. But what we do know is that it is one of the best explanations we have for the problems with the standard model of cosmology. Now, there are some people who disagree with the idea of inflation. They say that it's unnecessary, and that it introduces more problems than it solves. But the majority of cosmologists support the idea of inflation, and there's evidence to back it up. For example, the cosmic microwave background radiation contains tiny fluctuations that can be used to predict the distribution of matter in the universe. And when we compare the predictions of inflation with observations, they match up very well. Overall, inflation is a fascinating and controversial topic in cosmology. Whether or not you believe in it, it's definitely a theory worth talking about. So what do you think? You think inflation is real, or is there another explanation for the problems with the standard model of cosmology? Let me know in the comments below. If you liked this video, please leave a thumbs up, as it really helps us grow. Also, be sure to subscribe so that you don't miss out on any of our future videos. Thanks for watching. I hope you learned something new, and I'll see you next time. Now, here's another video that I think you'll enjoy. It's about the heat death of the universe.